Hey there, kiddos. It's time for another video. This is lesson 12 in module 6. I gotta go fast because I have to do carpool transportation, so let's get to this. Write a rule for the line. We're still continuing with our same objective, which you can find at the bottom. Create a rule to generate a number pattern and plot the points. And so we're going to be writing a rule for the line that contains the points 0, 3/4, and 2.5, 3 1/4. And so what you want to do always is look at the difference between the x and the y values. What is the difference between the x and the y values? Once you figure out the difference between the x and y values, you have your rule. Then you can identify an infinite number of points on the line by following the rule. So ask yourself, which one's bigger, x or y? Well, the y is bigger. By how much? By 3/4. Okay, so take that. Okay, we've got, if we have x plus 3/4 so far, I'm not sure that it's plus because it could be multiplying. You have to check out the lesson 12 template video to see how to sort that out. Now apply this to another set of points. Okay, what's the difference between 2.5 and 3 1/4? If I go up a half, that gets me to 3, and then another fourth, it gets me to 3 1/4. So I can add 3/4 to x to get y. So that is the rule. Okay, add 3/4 to x to get y. And once you have your rule, which I always like to put straight in algebraic format, so you have variables, the equal sign, it's a number sentence, then you can apply it. You can create any x values, and then as long as you apply the rule, you should get the correct y value, and you should be able to plot those points on a line. So I'll just give you a couple of points if you can't think of your own, but you can certainly think of your own. Notice that this number line here, okay, it has fractional units. 1, 2, 3, 4 pieces in a whole. That means that each one is 1/4. And notice that I did 1/2, but you can also do 2/4 if that makes you happy. 3/4, and do that over here just to remind yourself what you're counting by. Young 5th graders are not, real practiced or versed at counting in fractional units. So you may want to start labeling things to help yourself along so that when you have to plot points, you can find your way through all these little lines. Okay, so let's say I'm using 1 1/4. Okay, then I'm going to apply this formula. So I take my 1 1/4 and then I add 3/4 to that, which would get me up to 2. Write your ordered pair, put it in proper format. We'll put that on the graph in a moment. Think of another point. You can make up your own. It doesn't have to be what mine is. This time I'll use a whole number. I have to try to start using more fractions so you guys get used to seeing that. Plus 3/4. Make your ordered pair. And let's plot these points, okay? So 0 3/4 would be here, and then 2.5, 3 1/4, and then up to 3 1/4. So we have like a beginning and an end, but we're going to have other points in between. 1 1/4, so 1 1/4 is on this first line unlabeled, and 2. And then 3 out here, that's further, and then 3 3/4 right out here. Okay, and then you also want to not just have a string of dots that don't have any labels, but we want to put the labels with it. So point B, 1 1/4 and 2, and then 3 and 3 3/4. Okay, so let's connect these points. Okay. And Do we have a, nope, we don't have a letter for this line. Sometimes you do, sometimes you don't. This could be line BC if you wish. So we did the 2 more points, we drew the line. Now let's write a rule for a line that is parallel to line BC. Here it is, line BC. And it goes through point 1, 1/4. Okay, so 1 for x, first number is x. The second one is 1/4, that's y. So put your point there. And now I need to come up with the rule that will mathematically get me from this x to this y. Remember, it's just sort of about calculating what's the difference between it. Now, this one was a plus 3/4. Notice we are now below the midpoint, below it. Okay, so notice that y is less than x. So you should be thinking about subtraction. So whatever your x is, we're going to subtract, and how much smaller is 1/4 than 1? Well, it looks to be 3/4 smaller. So if this is my rule or my formula, then I could apply all these other points. I could apply the rule to all the other points and just make up all the x's and then create a line that goes through this point. Okay, so that's basically what we're going to do. So 1 1/4 and then 3 3/4. So if I move or create my formula and now, okay, sorry, let me go back. Write a rule for a line that is parallel to BC. So this one could be parallel right here. Now I have a whole new set of rules. Same point, 1 1/4, and a different set. So this can be parallel, okay, but this one will not be parallel. So it's a different rule and it's a different line, not parallel to this one. Okay, remember, in order to be parallel, it's got to go addition or subtraction. Okay, now look at this one. If I have this point 3 3/4, that's a difference that is greater than the one we just figured out. Okay, so 1 minus 3/4 would give us 1/4, but 3 minus 3/4 would give us 2 1/4, not 3/4. So you have to start thinking mathematically. How can I get this one? How much? What is the difference between here and here? That's quite a bit. Okay, is it half? It's less than half. Is it 3/4 of it? Or how many fourths is it? So let's look at mathematically what we can do with other points to figure it out. Let's try 2. Okay, so if I remember that for x, it's always easiest to start with a 1 or a 2 for your x value so that you can apply the formula. And if you're trying to figure out what the formula is, you want to use a whole number as opposed to fractional units. So if this seems to be only about 1/4 of what this is, y seems to be about 1/4 of x. Okay, what if I multiplied y times 4? Would I get x, for example? Okay, cross cancel, and I get 3. So noticing that when I multiplied by 4, going the reverse direction, that I will get 3. That means that if I have x, I'm not going to multiply by 4, I'm going to divide by 4. It's the opposite operation from x to y as from y to x. So if you multiply y, this is y, okay, and if I multiplied it by 4, then if I have x, I'm going to divide by 4. And right now, when I'm going from x to y, this is 1/4 the value of x. Okay, so y is 1/4. There's no room here. X divided by 4 equals y. That's one way to write that. You could do x times 1/4, or like 1/4 of x equals y. That's another way of doing it. Okay, so those are different ways to think about these numbers and their relationship. Now again, if you want to create 2 more points on this line, and you're going to take your x, okay, and we have this fractional unit. Oh, there go the lights. It's so nice that the sun is still shining. If we have fractional units or a smaller number, if I have 2 divided by 4, I get 2/4 or 1/2. Okay, you could put either one and just, it's going to be right here on your, actually this is x, sorry, it's going to be right here on your number line. So try to use simplest form. That's what you'll see on your number lines most of the time. If you continue and just say, use another whole number like 4, okay? If x is 4, well, 4 divided by 4 would give you 1. Now we finally have 2 whole numbers, so we can easily plot these points on the grid. Okay, now we're going to, these are the 2 additional points. We're going to draw the line on the grid on the right. So 2, let me get the other one. This is 1 and 1/4. This, I need 3 and then 3/4. Those are unlabeled, and then we're going to do point G, which is 2 1/2. G, and then 4 and 1. H. All right, let's make your line. There you go. This is line GH. And let's see, create a rule, got that, 2 more points, did it, draw the line on the grid, good. Write a rule for a line that passes through the origin and lies between line BC and GH. So this one passes through the origin, okay? And if it lies between this line and this line, but it passes through the origin, okay, then I can have the one that I was talking about earlier, where you just subtract and you get a line that's parallel and yet below. So what if I have, remember the origin has the exact midpoint. What if I had x equals y? Would that work? What if I have 1, 1? What if I have 2, 2? What about 3, 3? That ought to confirm it for us, right? So, origin, other points on the line, passes through this, and it's between line GH and line BC, and it just so happens to be through the midpoint, okay? That would work, okay? So hopefully that one is clear for you. That should work. That is all done. Next page. We only have 2 more pages. Now this top part you're not going to graph. It's just math. So when you see these tables of value, know that sometimes we're just going to do the math that goes with it. Oh, and you guys get to create some rules. Look at you doing the creating the rule, but you have to look at the relationship between the numbers. So if I have this ordered pair, okay, for a line that contains the point 1/4 and then 1 1/4, using the operation or description below, so they're going to tell you you have to use addition for this one, okay? Well, thank goodness, because y is larger than x. By how much? That's what you have to ask yourself. What's the difference between x and y? Y is 1 larger. So x plus 1 equals y. Okay? Now, come up with 2 other points on this line. You can make up your own x value, and then you just need to add 1 to it in order to get your ordered pair. You can do anything. You don't have to follow my example, okay? If I did, let's see, this graph happens to be, I'm going to use this one just as a sample, even though we're not going to put these on here yet, or we'll do something different. But look here, this has many, many lines before they label this actually in the wrong place, because it shouldn't be in the space, it should be on a line. But what if I have tenths? Okay, can I do that? Yes, I can. Can I do fourths? Yes, I can. So if you want to have like a half, then a half plus 1 would be 1 1/2. It can be as simple as that. Or you could have like 8/10. Okay, so if you want to do something fancy like that, then your y value would be the plus 1. Yes, you can put a 0 here. Okay, so you can have anything for x, and I would recommend keeping it either all fractions or all decimals. All right, now what about a line parallel to the x-axis? Okay, so if your line is parallel to x, you know that the x-axis goes this way. It's at the bottom. So then all points have to have the same y value. Y is the same. Now, can you come up with a y value? Yes, you can. You could say y equals 4. You could also say y equals 8/10. You can have y equals 1 6/8. I don't really care, and it does not matter, because whatever y is, all your x coordinates are going to be different, and your y will always be the same. Okay, so pick one and stick with that. Okay, any of those would be fine, but just stick with one. Don't want you to think you can change it all up. So let's just say y is 4, then y is 4, and you can put anything. You can put like 1 or 2 or 8/9. It does not matter, because y is always going to be 4, or whatever you decide. Okay, let's do another one. Multiplication. Multiplication. So we can come up with anything that you want, okay, for this rule. Let's say we multiply by 5. X times 5. What would happen with this if I did x times 5? Okay. Come up with 1. Let's take our 1/4. Okay, what if we start with 1/4? And multiply that by 5. What do you get? 1 1/4. Okay, so if you're going to use these points, which you probably should do, then you could use like 2. 2 plus 1 is 3. 2 and 3. And if you want to use, instead of 8/10 and apply it, you want to use this one, it would have to be something simple. Okay, you can use these, but if you're stuck, you can use a whole number. All right, so back to here, 1/4, 1 1/4. What if you use just like a whole number, like 1? 1 times 5 is 5. And what if you want to use something different, like a fraction? You can do a half. Okay, half of 5. Oops. half of 5. 1/2 and 2.5. There's your ordered pair. Okay, how about another one? A line parallel to the y-axis. Now remember, when you're parallel, you have to be like constant. If you're parallel to x-axis, then y is always the same. If you're parallel to y-axis, then x is always the same. Whatever. So if you say x equals 1 1/4 or 1/4, actually this one, if we use this, x always has to be 1/4. If you use this one, y would always have to be 1 1/4. Okay, so if you use these points, y has to be the same. If you want to have any line that is parallel to the x-axis, y can be anything. For this one, it would be 1 1/4. All right, a line parallel to the y-axis. If x is the same, then it would be 1/4, always. And y can be anything, okay? You can literally put in anything. It can be 1 1/4. Use the one from above, if you wish. Okay, so 1/4, 5, 1/4, 10, 1/4, anything. Okay, and so there you have your line parallel to y. Okay, just like that, always on the 1/4. Now this last one, we have a multiplication with addition, and that means you have to have a two-step problem. Now if you're trying to get this, the 1/4 to here, okay, you have to keep it really, really small, because obviously there's not much of a difference between 1 1/4 and 1/4. So you can come up with, say, something that is like multiply by 2 and then add 1. Okay, that's a two-step problem. You can do like multiply by 4, and you can add a fractional unit. Okay, multiply by 4. This is, remember that tiny little fraction. 1/4 times 4 gives you the 1, and then if you add the 1/4, you're going to get that y. Okay, so if you want to get the 1/4 and then the 1 1/4, you would use this formula. And so other points on this line, for example, let's try 2. I always like those whole numbers. 2 times 4 is 8, plus the 4th, 8 and 1/4. Okay, what if I have like a 4? Actually, let's use a fraction. Let's use this tiny little fraction. 1/2 times 4, well, that's going to give you 2 1/4. And then you can plot that. But we're not plotting yet, but those would be your ordered pairs. Okay, let's hustle on to over to Mrs. Boyd. Now she asked her students to give a rule that could describe a line that contains the point 6/10 and 1 8/10. Remember, this is in tenths. 1, 2, 3, 4, 5. Let's label that. 6, 7, 8, 9, 10. And so the 10/10 should be right here. Okay, their printing is not good. So move that over a wee bit. Avi said the rule could be multiply x by 3. See, if I did 6/10 times 3, I would get 18/10. True. Ezra claims that this could be a vertical line, okay, and that the rule could be x is always 6/10. Well, if that was true, then x would always be here, and it could be a vertical line, and it could pass through that point. Mrs. Boyd says, Eric thinks the rule could be add 1.2 to x. Well, if you add 1.2, you certainly would get 1.8. So I have all these options that I can do, and they would create different lines. So Mrs. Boyd says all the lines they are describing could describe a line that contains the point. Explain how it's possible and draw the lines on the plane. So let's first take a look at where this point is. 6/10 and then 1.8. Here's the 1, and then 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is our point. Now, if I was to follow the rule that says x is multiplied by 3, and I'm going to do a little bit of math work down here. If I take the 6/10 and I multiply by 3, I get 18/10. But I need another point. So let's take like 2/10 and multiply that by 3. So if x times 3 equals y for this rule, then 2/10 times 3 would make 6/10. Let's plot that. 2/10, and then, let's see, 5, 6 would be here. 1, 2, 3, 4, 5, and then 6/10. So this is Avi's rule. Okay, and I have 2 points on the line, so I'm going to go ahead and connect and say Avi. And then Ezra, it could be vertical. X is always 6/10. So if the rule is that x is always 6/10, that's going to be right through this, like so. And that's Ezra. Okay, and that is true. Look, they both pass through that point. And then Eric says, what if I just add? So if the rule is x plus 1.2 to get y, and we have our x and y values, and for the first one, he says, let's just add, let's give it another point. So what if I add to 4/10? So 1.2 would be 1.6. So 4/10, and then 6, 7, 8, 9, 10. That goes here. Sorry, their numbering is a little bit off. So 4/10, and then 1, 6. Okay, so this is going to be a steeper line. And, or it's not as steep as this one. So we have this point where they all meet, and now I have this line. Okay, this is Eric. Okay, so they all have different lines. That's what this is trying to get you to notice. They all have different lines. You have to apply the rule. All 3 rules could go through the same point, okay, as they do here. One could be vertical. You could even have a horizontal line. That could be another rule. All right, well, let's try to zip on to this last one. I think because sometimes I run out of time, what I'm going to do is throw down the answer key and talk quickly about this one so I don't get cut off. This is a super long video. Create a mixed operation rule for the line that contains the point 0 and 1. So notice that I put that it's difficult to calculate sometimes with a 0 and a 1. So it's easier to use a whole number like 1 and 3. If this is only 1 larger, but this one is 2 larger, then what you want to do is look for what ways you can get from here to here in 2 steps. So multiplying something first would be okay, because when you multiply by 0, you get 0, and then you have to add 1. So if you multiply by 2, and then you still add 1, you can get the 3, okay? So you can check it by having, say, 2 as your x, or 4 as your x, and those should give you some good number points. However, keep an eye on the number lines here, because you should only try to come up with points that, after all your calculating, will get you to 5. So good points for point O and P would be starting, say, with a half, and then you apply that. A half times 2 is 1, 1 plus 1 is 2, and then 1.5 times 2 is 3, plus 1 is 4, so your 2 points could be that. You can have other points as well, but you're going to be off the grid if you get over 5. Then you'd have to plot the points and make sure it's straight. Finally, write a rule for a line that is parallel to line OP, this line that you're going to make here, right here. And if it's parallel, remember you're just going to add or subtract, and you can do the same multiplication. Notice the notes. Do the same multiplication, but that'll give you the proper slant, but you just have to add a different number. Okay, add a different number, plus a half, plus 3, plus 1.5, and then try all these different combinations. So we're out of time. It's over 30 minutes, and I will have to see you on the next video. Sorry it's so long.